All right, so in this video, I want to talk a bit about domains and ranges and interval notation. So if we just look at the number line, if you have the entire number line shaded in, that's the set of all real numbers. Interval notation, you would have parenthesis negative infinity, comma, infinity. And that means that that is the set of values of all real numbers. If you look at this number line, this contains the set of numbers between A and B. This is called an open interval because the endpoints are not included. And the interval notation is parenthesis A, comma, B, parenthesis. Parentheses in interval notation indicate that the endpoint is not included in the set of numbers. So the set of numbers goes up to, but not including that endpoint. A bracket indicates that the endpoint is included, and we'll see some examples there. Anytime your set of values goes toward infinity or toward negative infinity, you never put a bracket on infinity or negative infinity, because that the infinity indicates that the set of numbers continues to increase without bound. So you can never include the endpoint there. Here, this is a half open interval. Notice the endpoint, left endpoint A is included. So the interval notation is bracket A, comma, B, parenthesis. This corresponds to the inequality here, where you would have an or equal to inequality on the A and a strict inequality on the B. This one, this is the set of numbers greater than A. Notice the inequality is A is less than X, or you could reverse that and write it X is greater than A. And the interval notation would be parenthesis A, comma, infinity, because neither A nor the right endpoint are included in the interval. This is the closed interval, A to B. This means all the set of values between two numbers A and B, including the endpoints. Notice that the interval notation has both A and B in brackets. Here, this is another half open interval. It's just the right endpoint is included. So it's similar to this one, just the other endpoint is included. Notice the brackets on B because it's included, but parenthesis on A because it's not. Similar to this, but reversed. This would be the set of all numbers greater than or equal to A. Notice the distinction from this one where the endpoint is not included. It's a strict inequality and there is a parenthesis. Notice the endpoint included here. It's an or equal to inequality and a bracket on the A. Similar thing going on here with the B, the difference between the set of all numbers less than B. B is not included in the interval. It's a parenthesis. It's a strict inequality and an open circle. Here, B is included. Notice B has a bracket, next to it, and this is an or equal to inequality. All right, so let's talk a little bit about identifying domains and ranges of functions. So we want to identify the domain and range of each function and then sketch the graph. So if you have f of x equals 1 over x, the domain is the set of all x values that make sense to plug into this function. You could plug in any number you want except what? 0, right? So the interval notation would be, you always go from left to right, negative infinity to 0, and then parenthesis because 0 is not included. And then you put a little u, that means union, 0, comma, infinity. All right, so this inequality here would be x is less than 0. This inequality would be x is greater than 0. Okay, so that's how you would express it in interval notation. The range is the set of all y values. Now the function 1 over x is the parent reciprocal function, and you should be kind of familiar with this function. If not, when we draw the graph, you'll recognize it. The range is actually the same set of values. It's the outputs, it's the y values associated with this function. So negative infinity, comma 0, union 0, comma infinity. All right. Now, when we sketch the graph of this function, it looks like this. It has a vertical asymptote at x equals 0, or the y-axis is a vertical asymptote, and it also has a horizontal asymptote on the y-axis, or excuse me, the x-axis, a horizontal asymptote at y equals 0 there. Okay, so that's what the graph of the function looks like. Let's do one more. F of x equals 1 over x minus 2. Now this is almost the same graph, except you're subtracting by 2 in the denominator. I'm going to sketch the graph first in this case to show you kind of what happens. Now, if you remember, if you subtract a number inside the function, what we're doing here, that moves the entire function horizontally 2 units opposite the direction you would think. So it's actually going to move the whole function of 1 over x to the right 2 points. So you're going to have your vertical asymptote there, and then the function's going to do those curvy things like this here. So you have a vertical asymptote at x equals 2 and a horizontal asymptote at y equals 0. The domain is a set of all x such that you go from -infinity, but not to 0, but to 2, because you can go all the way up to 2 without getting a 0 in the denominator, and then from 2 up to infinity. Notice the parenthesis on 2, because 2 is not included. The range is the same as the previous problem, infinity to 0, union 0 to infinity, because you could see that the y values for this function include everything, but they never hit y equals 0 anywhere. All right, guys, that's it for identifying domain and ranges. Hope that was helpful to you.